So in this video, we're going to talk about matrices, which you've seen before, but we're going to do addition, subtraction, and then scalar multiplication. And we will take a look at both how to do that first longhand, and then we'll look at how to do that in Desmos, which you can also do on your graphing calculator. But matrix is rectangular, array or arrangement of numbers enclosed in a single set of brackets. So, for example, 5, 7, 0, 1, 4, -3. So we have columns and we have rows. Excel is kind of an example of a matrix too, with the rows and columns. So the order or dimensions is its size. So we would say rows by columns. So let's go ahead and kind of give an example over here. So these right here are rows. So row 1, row 2, row 3, and then up here we would have column. No, yeah, I've got enough room. Column 1, and here column 2. So this would be a 3 by 2. 3 rows, 2 columns. So that's its order or dimension. An entry are the numbers in the matrix. So and then the address would be the location of each number. Or entry. So, for example, A to 1, this is the row, and this is the column that you would find that entry in. So for this example right here, row 2, column 1, 3. If I had A, 1, 2, then I would go row 1, column 2. And then if it asked for A2, 4, column 2, 4 we don't have, so it's not able to find that because there isn't a 4th column. A square matrix has the same number of rows and columns. So for example, a 2 by 2 or a 3 by 3, or a 4 by 4. Row matrix is a matrix with a single row. So for example, a 1 by 4, something like 1, 4, 6, 8. Fix my bracket there. column, needs to be an N, column matrix has a single column. So, for example, 1, 2, 3. So this would be a 3 by 1. All right, so let's take a look at the given order dimension of each matrix. So for this first one, for W, we have 3, and then 1, and -2, and 0. So we have the dimensions would be a 2 rows and 2 columns, so a 2 by 2. For Z is right here. So we would have how many rows? 2. How many columns? 3. So again, this is our size kind of that we're looking at when it asks for dimensions. The entries are these specific numbers. So remember that first one is our row. The second one is the column, and then which one it comes from, W up here. Okay, so we're going to go to W, and we're going to look in row 2. That's row 2, and we're going to look in at column 2. So 0. So go ahead and try Z1, 3. So row 1, third column should have 3. Right, adding and subtracting. So you can only add and subtract matrices if they have the same dimensions. So if it is a 2 by 2 and you're trying to add a 2 by 1, you cannot do that. They have to be the same dimension, same size. So let's take a look at this first one here. X minus Z. So we're going to take our X and we are going to, I'm going to go ahead and write it out so we can see it down here, but 4 and 5 and 7 and 1 and 2. And we're going to subtract Z. So first let's see, are they the same dimensions? Can we actually add or subtract them? 2 by 3, 2 by 3. We're good to go. So we are going to take and add. I'm going to kind of do color coordinate. There we go. So 4 and then minus. One thing that you can do is you can change this into a plus and then change every single sign in here. And then that way it's easier to just add versus having to remember to subtract. So 4 plus -2 is 2. Sorry, I forgot my color. There we go. And then we're going to take 7 plus 2. And then we would take 2 plus -3. And then do the same thing for that bottom row. 5 and -1. 4. 1 and 0 is 1. And last, -1, -4, -5. And there we go. So for x plus y, we can see that x has the dimensions of 2 by 3. And y has the dimensions of 2 by 2. So can we add these together? No. Not the same size. So NA, we cannot add those together. All right, multiplication. So scalar number multiplied to each entry. So it's this big number out front, this kind of like coefficient here. We're going to take 3 times every single number in Q. So I'm going to take 3 times 4, 3 times 7, 3 times 2, and all of those entries. So 3 times the whole thing. So what we get is 12, 15, 21 there, 3 there, 6, and -3. Okay, so if you want to try B, go for it. You're going to take 2 times P and then subtract R. So try it and then push play and check when you're ready. So first thing I did was just double all of my entries in P. So I got 6, 2, 4, -4, 0, -2 here. And then I'm going to subtract R. So I just changed it to addition and changed all these signs to be opposite, so then I can just add. So 6 and -1 to get my 5, -4 and -4 to get my -8, etc. Double check your answer.